Welcome back, everyone. Now in this video, we're going to talk about inverses of functions, specifically the function model selection, construction, and application. I'm going to save that for a separate video just so that this video is not 20,000 years long. But yeah, we're just going to focus on inverses. So luckily for you guys, a lot of the inverses should be a review and a recap of Algebra 2. So just to kind of go through the broad strokes. So inverses are going to have quote unquote undo each other. In order to find the inverse, what we're going to do is we're going to switch the x and the y, and then we're going to solve for the y in order to find the inverse. So another really key important thing that's going to happen is your domain and your range are going to switch when you do the inverse. So from the original function to the inverse, those are going to flip. Or rather, I should have done from f of x to the inverse. So be careful when you're writing f of -1 of x versus just inverse, because the inverse of x, or here, let me just write this down. So more specifically, if I just say inverse, this does not have to be a function. But if I were to write f of -1, or f -1 of x, which is the inverse, this must be a function. So just be careful when you're writing inverse right here, because that gets mixed up with a lot of people. So just continuing on, when you're doing inverses, what's going to happen, the two functions that you find, or once again, the inverse, not the inverse function necessarily, the inverse and the original function are going to be reflected over the line y equals x. So that's another way of saying that your values or coordinates are just going to flip. So if we just give you a graph, you can just flip the points to find the inverse. So that's going to be another really handy tool to know. And then, as I was just saying before, not every inverse is going to be a function. So the original must pass the horizontal line test in order to be what we call one-to-one, which this is just a fancy mathematical way of saying it passes the horizontal line test. So we're going to look at all these details later on. So, and then in order for the inverse to be a function, if it's not a function, we may restrict the domain of the function so that the inverse will be a function. So we're going to get more into this later on, especially when we get to inverse trig, but for right now, we're just going to focus on the algebraic kind of side of these. So, and then in addition, with inverses, we're going to be doing compositions. So compositions of these functions, or rather, ... when you do the composition of the original and its inverse, both ways, you should get a result of a positive 1x. Anything else would tell you it's not an inverse of each other. So once again, we're going to get into all this throughout the video, but we're going to start just from square one. So first off, we want to find the inverse of f of x, which is 2x plus 4. And then we're going to graph both f of x and the inverse on the given graph. So I'm going to do this two ways. So I'm going to do it both algebraically and graphically, just to kind of give you a lot of background as to how you could do these. So let's just start doing this algebraically. So first off, our function f of x, that's the same thing as doing y equals. So I'm going to have y equals 2x plus 4. And then if I want to find the inverse, what we're going to do is flip the x and the y. So I'm going to have x equals 2y plus 4. So now what you do, once you flip them, then what you're going to do is you're going to solve for this y value. So you're going to do your inverse operations. So I'm going to, of course, subtract 4. So x minus 4 equals 2y. I'm going to go ahead and flip the sides because we always want the variable we're solving for on the left side. And then when you get here, I still need to get rid of this 2, so I'm going to divide everything by 2. Another way of looking at it this way is you could also multiply both sides by 1/2, which I've noticed I see students making fewer mistakes when they look at it this way. So this would give you y equals 1/2 x minus 4. And then I'm going to distribute that 1/2, which this would be 1/2 x minus 2. So this would be your inverse function. So as we know from our linear equations, this is for sure a function. It passes the vertical line test, so I could write it as inverse of f. So now what I want to do is I want to graph the original and the inverse on the grid that I have over here, just to kind of see how these kind of work. So what I want to start with is I'm going to graph the line y equals x. So on this 10 by 10 grid, so I'm going to graph the line y equals x. I'm going to make this line kind of fade into the background a little bit. I don't want to bring a lot of attention to it, but I do want to be able to see it. Now I'm going to graph the original function. So we're going to have a slope of 2 with a y-intercept of 4. So I'm going to start at 4. And then we're going to do a slope of 2. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. And then if I'm going to go the other way, I'm going to go down 2, left 1, down 2, left 1. And I want to just keep that pattern going. Now I'm going to plot every single possible point I can on purpose for the next part. Okay, and then I'm going to extend this line a bit. Ideally, when you're graphing, you want your arrows to be off the graph. All right, and then I'm going to graph my inverse, which is going to be 1/2 x minus 2. So I'm going to have a slope of 1/2 and then a y-intercept of -2. So start at -2 and then do a slope of 1/2. So up 1, right 2. There we go. And there's our arrows. So as you can kind of hopefully see, if you visually kind of look at it, even if you need to tilt your page or screen or whatever slightly about 45 degrees to the left counterclockwise, hopefully you can kind of see that they are kind of mirror images of each other. But more specifically, I want to look at the points. So more specifically, let's take a look at our original. So I'm going to take this point here, which is 0, 4. And as we mentioned for the inverse, if you flip it, you get 4, 0, which so happens to be right over here. And then if I take the coordinate, my next coordinate, let's say 1, 6, if I flip it, we get 6, 1, which so happens to be right over here. And then so on and so on. So then if I take 2, 8, then we're going to get the coordinate 8, 2, which is right over here. So even if we were to just give you the points, you can just take the points and then you can just flip them. So if I have 3, 10 here, that would take me to 10, 3. So that's why I wanted to list out all those points. That way you can kind of see these points are going to be inverses. We're flipping the x and the y values to get the inverse point of that same graph. So now we're going to look on to another shape. So first off, we're looking at f of x, which is on our grid, which is a semicircle. And then we're looking to see, is f of x a function? So when I'm asking if the original is a function, we're looking specifically at the vertical line test. So does it pass the vertical line test? Yes, it does. And then all the functions, so now parts C and E are going to focus on the original, whereas the right side is going to focus on the inverse. So I'm going to go ahead and fill out the entire left side first. So the domain of f of x, which is going to be all the x values. So we're going to go from -3, that's a 3, that's a 3. I don't know what it is with 3s. I can never draw a 3. So -3, 0, going all the way to 3, 0. So my domain, of course, we're going to focus on the x values. So that would be from -3 to +3, and I'm going to use brackets since we have closed endpoints and they're filled in circles. And then the range, well, the lowest we go is going to be at 0, but then we go all the way up to 0, 3. So that would be from 0 to 3. So just as a quick little recap, domain, we're looking at this, essentially kind of the spread left to right of your value. And then the range, we're looking as to how far up and down your function's going. Or graph, rather. I need to stop saying function. All right, so now that we have this information about our original, now we can look at the inverse. So they don't really give us an equation or anything. So in this case, because you don't have an equation, you're actually just going to transform the points. So just like what we did previously. So I want to transform the point -3, 0 to find the inverse, which is going to transform into 0, -3, which is going to go down here. So 0, -3. Once again, I can't draw a 3. And then I'm going to transform the point 0, 3, which is going to go to 3, 0, which is going to be right on top over here. And then I want to transform the point 0, 3, or nope, 3, 0, which is going to transform into 0, 3. So we are going to have a good amount of overlap. So your original, which is the semicircle, the upper part, now we're going to go to a semicircle, but we're going to have just the right part. So I'm going to attempt to draw this. I'm going to get a little creative. I'm going to draw a circle. This is one thing I do love about Notability. Okay, close enough. Then I'm going to use my partial eraser since I just want the right side. And then get rid of that. There we go. Close enough. So when I draw my line y equals x, the grid's not exactly symmetric. So this would be y equals x. So it is a nice little reflection. So now we're going to look at the inverse. So if I look at the inverse, we're looking at this purple right-sided semicircle. So what I want to focus on first is the inverse going to be a function? Well, no. It fails a vertical line test pretty badly. So, no. My favorite answer to any math question. Now we want to look at the domain of the inverse. So notice over here how I didn't say domain of inverse of f, because if I were to write inverse of f, that would insinuate that it is a function. So we're just going to write inverse to stay kind of broad. So the domain, we're going to go from the far left, which is going to be 0, to the far right, which is going to go to 3. So we're going to go from 0 to 3. And then for the range, we're looking to see how far up and down your graph goes. So it goes all the way down to -3, but it goes all the way up to +3. So this would be from -3 to +3. Now, take a look at your attributes of everything I just wrote, and I want you to really kind of look to see if you can notice a pattern, which I pointed it out earlier, but I want you to see if you can actually visualize it. Notice how the domain of the original is the range of the inverse, and how the range of the original is the domain of the inverse. They're gonna flip, which is one thing that we mentioned up here, which, somewhere up here, oh, here it is. Domain and range are going to flip when you do the inverse. So that's going to be a really important idea to know, because some of your questions, we may ask you, what's the range of the inverse, which is just a very fancy way of saying, what's the domain of the original, so the OG. So if I want to know what's the range of the inverse, you can just tell me the domain of the original. Or if I want the domain of the inverse, you can just tell me, well, the range of the original. So that's kind of a really neat little shortcut. Okay, so now we're going to do the same idea. So I would say pause here, try this one on your own, or you can just watch me do it. It's up to you. But I would definitely say try to pause here, try this one on your own. So given f of x, we're going to focus on the left side first. So f of x is already given on this grid, no equations given. So what I am going to do is take these points and identify the original. So 1, 2, 3, 4. So this is 0, 5. And then we have 1, 4. Looks like it's going to be a square root function. So that means this point would also be a good point, which means this should hopefully be 9, 2 if I can count. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Perfect. So now that I have those 3 points, I want to go ahead and flip the points so I can get my inverse. So flipping 0, 5 is going to give me 5, 0. So right here. And then flipping 1, 4 is going to give me 4, 1. So right here. So let's go ahead and try to label these. I'm going to label these without it getting too muddy. All right, and then I want 2, 9, which is going to be up here. So when I draw my graph, it's going to look something like this. Whoops, not like that. So I'm going to this is a square root curve, so I'm going to put an arrow on that end so that I can do an arrow on this end. So by hand doing it, not bad. So now let's look at what we got. So let's start with the original first. So is the original a function? Yes, it is. It passes the vertical line test. What's the domain of f of x? So the original, so we start at 0, and then we're going to go on indefinitely. I'm going to go ahead and put that arrow there. So we're going to go from 0 to infinity. And then the range is going to go from 5, and then we're going to go down indefinitely since we're treating it like a square root function. So that means the range would be from negative infinity to 5. So then if I look at the inverse, now we're looking at what's in blue. So is the inverse a function? Yes. So the domain of the inverse, I'm not even going to look at a graph. I'm just going to make a flip, and then I want to check the graph to see if it's consistent. So based on the information, the domain should be from negative infinity to positive 5. And then the range should be from 0 to infinity. So now I'm going to look at the graph and see if it's consistent. So if I look at the domain, it's going to go indefinitely like this. I'm going to exaggerate it a little bit. It's going to go indefinitely to the left. So it would go from negative infinity all the way until we get to 5, which check. And then for the range, we're starting at 0 and we're going up indefinitely. So that checks out too. So I didn't even need the graph. I can just know to make the flip, and then I'm good. All right, so now this is going to get into more or less what a lot of your problems are going to look like. So given the following functions, you want to find the following. We're going to give you a graph, or an equation rather, and you want to find the inverse. So when I say find the inverse, you need to find the inverse algebraically. And then we're going to find the attributes of the original, the attributes of the inverse, and then we may or may not ask you to graph it. So with this one, so we're starting with f of x equals x plus 2 all squared minus 5. I'm going to change this into y equals x plus 2 squared minus 5. So when I do the inverse, once again, you're going to flip the x and y. So x equals parentheses y plus 2 squared minus 5. Now I'm going to add 5 on both sides. So x plus 5 equals y plus 2 squared. I'm going to go ahead and flip the sides. So y plus 2 squared equals x plus 5. Always like having the variable I'm solving for on the left side. So over here, when you get here, now I need to get rid of that squared. So I'm going to take the square root of both sides. But when you take the square root of both sides, what you've got to account for is the positive and the negative value. So we're going to have plus or minus square root of x plus 5. And then I need to move over that 2. So I'm going to have y equals negative 2 plus or minus the square root of x plus 5. So you could write this a few different ways. You could also write it as plus or minus square root x plus 5 minus 2. I mean, I will say we're definitely going to prefer this top way rather than the bottom, but we would take either one. So this would be your inverse. So if I look back at my original, now we're going to go ahead and find the attributes of the original. So this is in vertex form. So my vertex is going to be at negative 2 comma negative 5. And let's go over here. Negative 2, negative 5 is about right here. And then when your a value is one of a quadratic, I like to use the square differences kind of pattern to graph the rest of it. So meaning from the vertex, I'm going to go up 1 over 1, and then up 4, and then over 2, and then up 9, and then over 1. And then we're just going to keep using those perfect squares. So my original is going to look something like this. Okay, so my original graph is going to have a domain of all real numbers. It never stops going left or right. And then the range, the minimum value it's going to reach since it's facing up, our minimum value is going to be negative 5. So I want from negative 5 to infinity. All right, and then I don't even need to graph the original or graph the inverse to know that the domain and range are just going to flip. So my domain is going to be from -5 to infinity, and then the range is going to be all real numbers. All right, now looking at my graph, now we're going to go ahead and graph the inverse. Now, one thing I do notice, if you look at your parabola here, it is not going to pass the horizontal line test, which means the inverse is not a function. So in this case, we're going to go ahead and graph the inverse. Just know that it's not a function, but that's okay. So I'm going to go ahead and plot my line, y equals x, which you don't have to do this, but I like doing it in terms of a visual. That's just me. So once again, I'm going to put it in the background. Whoops, I don't want it to disappear. Not duplicate, hello, style. Close enough. All right, so now for the inverse, I'm going to take this point by point. So my original, we're going to have 1, 1, 2, 3, 4. So 1, 4, 0, -1, -1, comma, -4, -2, -5, -3, -4. I can never draw a 3. -4, -1, then -5, comma, 4. So those are all the original points. So now I want to use those to kind of give me my new points. So it doesn't really matter where you start. I guess I'll start up here. So -5, comma, 4 is going to flip into 4, comma, -5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And then -1, -4, 1, 2, 3, 4. Then -4, -3, so 1, 2, 3, 4, 1, 2, 3. Then -5, -2. Then -4, -1. -1, 0, and then 1, 2, 3, 4, 1. So your inverse is going to look something. Let's see if I can do this in one stroke. Close enough. So that's going to be your inverse. It's going to be a parabola on its side. So what's actually going to happen is notice how when you found the inverse, it's actually going to be a square root function. But when you actually look at your function a little bit more in detail, your inverse is actually going to represent two functions. So we have y equals negative x plus 5 minus 2, but we've also got y equals positive root x plus 5 minus 2. So we have two square root functions that are just going to be connected to make it look like it's a continuous parabola. So the top half would be, of course, the positive part, and then the bottom half is actually going to be that negative square root curve. There we go. So this is actually kind of two functions in one. And notice how I said functions in that case, because if I look at them individually they pass the vertical line test, but when I put them together, it doesn't. All right, now looking at this next one. So this one's going to be kind of annoying. So once again, we're going to start with y equals parentheses x minus 1 cubed all over 4, and then plus 2. I'm going to go ahead and switch my x and y. So we're going to have x is going to be equal. So y, make sure I switch my colors, minus 1 cubed over 4 plus 2. So start doing my inverse. So first I'm going to get rid of this plus 2. So I'm going to subtract 2 on both sides. And then I'm going to rewrite the divide by 4. I'm going to rewrite it as 1/4. I think that helps a lot of people. I think. At least in my experience, it does. So now I need to get rid of this 1/4. That's dividing by 4. So I'm going to multiply both sides by 4. But when you multiply, you got to make sure you put the entire left side in parentheses. So this is going to be 4 parentheses x minus 2 equals y minus 1 cubed. And then what I'm going to do, there's a couple different ways you can actually write or do this next part. I've seen some people where they like to take a cube root of both sides to get rid of this cube, which that's perfectly fine. I've also seen where some people prefer to just raise it to a 1/3 power, but it's all the same, so it doesn't really matter. I think I would prefer the 1/3 power. I think it just looks a little cleaner, but that's just me. I've seen it written both ways in AP. So we're going to have everything raised to a 1/3 power. So that's going to give us 4 parentheses x minus 2, all raised to a 1/3 power, which is equal to y minus 1. And then when I add the 1, I'm going to have y equals 4 parentheses x minus 2 raised to a 1/3 minus 1. So this is one way to write your inverse. Another way would be if you want to use the radical, but it's really personal preference. So if you are going to use the radical, just make sure you put that 3 in the index so that we know that we're doing a cube root. So either one. All right, so when I do my graph, so this is going to be, we're going to use the transformations to find our quote-unquote vertex, which is going to be at 1, 2. You know what, I'm actually just going to use Desmos on this one, because graphing this is going to be kind of gross. Okay, so y equals, where is my graph? There it is. X minus 1. I'm going to do everyone a favor and just show you an actual graph of it. To the third, all divided by 4. And then we're going to add 2. So this is going to be our original graph. So actually, let's do this. And I'm also going to plot y equals x so that you guys can see what we're reflecting over. Let's kind of make this a little small or a little thin just so you can see it but not bring a lot of attention to it. And then what's nice about Desmos, well, actually, let's do this. I'm going to plug it in a few different ways. So let's do y equals parentheses 4x minus 2. And then we're going to raise this to a 1/3 power. And then we're going to add 1. So there we go. That would be your inverse. Say, I don't think I can do a cube root. Or if you can, maybe, I don't know. It's probably in here somewhere, but I think just raising it to that 1/3 is going to be easier. Oh, I just saw it. Right here. There we go. So 3 in the index. Y equals, okay, 4 parentheses x minus 2 plus 1. So same thing. Like I said, it doesn't really matter how you write it. I would say if it's multiple choice, look at how the answers are written. If it's free response, mathematically, we would really accept any either one of those unless it specifically says write it using a radical. Okay, so wait, let's go back. So looking at, let's turn the inverse off. Looking at just the original, I can see my domain is going to be all real numbers and my range is going to be all real numbers, which means when I flip it for the inverse, it's going to be the same. So my inverse, or not my inverse, my domain of the original, negative infinity to positive infinity, and the range is going to be negative infinity to positive infinity. And then when you do the inverse, it'll be the same. So Desmos. Okay, now down here, now we're going to look at using compositions and proving that something is actually an inverse of one another. So what's going to happen is we're going to be doing function compositions. So that's what this last part down here is saying. When we do the composition of the original and its inverse, we should get a result of a positive 1x. So down here, so we're going to use compositions to prove whether or not these are inverses. So I'm going to do both f of g of x, but I also will need to do g of f of x. So we're going to start with f of g of x. So I'm going to take g of x and plug it in over here into f of x. So let's start with 3 parentheses, and then I'm going to do 1/3 x plus 1/3, and then minus 1. So when I distribute, so we're going to get 1x plus 1 minus 1, which is just going to give us a positive 1x, which is exactly what we want. So now I'm going to look at doing the other side. So now I want to take my f of x function, and we're going to plug it in to g of x. So when I do this, we're going to have 1/3 parentheses 3x minus 1, and then minus 1. Nope, 1/3. I knew something didn't look right. So when I distribute, that's going to give me 1x minus 1/3. Whoops, it's supposed to be plus. Then plus 1/3. Sorry, y'all. And then for this next part, we're going to combine like terms. So negative 1/3 and positive 1/3 are going to cross out. So we're left with a positive 1x. So there's that part. So they both are equal to a positive 1x when we do the composition. So what that tells us is, yes, they are inverses. And then if they ask for any justification, you would say, because f of g of x is equal to g of f of x, and they equal x. So this would be your justification. So now we're going to look over at number 7. Same idea. We're going to do compositions. We're going to prove whether or not these are inverses. So f of g of x. So I'm going to take g of x over here, plug it in. So 3 parentheses, negative 1/3 x plus 1, and then plus 3. So when you distribute, so we're going to get negative x plus 3, which is going to give me a negative x plus 6. So this does not simplify down to a positive 1x, so automatically not inverses. So no, because f of g of x does not equal g of f of x, which does not equal positive 1x. All right, and then down here are just some extra practice problems. So I went ahead and just worked them out just to kind of show you what type of inverse questions are fair game on what we could ask you. This is just finding the inverses on 8 through 13. And then you also have 14 through 17 here, where you also have to find the inverse, but then also use compositions to prove that it is going to be an inverse. So for 17, that inverse was a little rough. So I put it down here because there was not enough room, but it does work. So I also did the composition for number 5 just to kind of show you. But yeah, there's some really good problems, really good compositions. So make good choices.